Thank you so much. So yeah, this is going to be kind of a high-level description of roadmap-ish, discussion-ish, kind of a little more details than what Luke and Sai have already been talking about. I definitely plan on people can definitely raise your hand or ask questions in the middle. This is we'll kind of see how this goes. So to start off, I kind of want to give a bit of an overview of the precise tooling that we have today. Kind of these are sort of the injection points that we as designers or kind of shepherds of the component model have to kind of leverage and have to kind of manipulate here. So a lot of integrations typically start with WIT, as we have seen, and then this is where a tool like WIT bindgen is going to come in, which will actually generate some sort of guest language binding. So we have this, for example, for Rust and Go and C. But this also exists in forms of other languages, and I'll kind of explain that a little bit. But the general idea is there's some form of take the WIT, generate some sort of guest language stuff, and get bindings from there. A lot of times this will then involve some sort of compiler, which then generates a core assembly module. And the reason I want to call this out is that we don't currently have any compilers that natively emit a component. So everything is still talking about core WASM under the hood, which means that this is sort of the primitive that we are building on. This is kind of the reason for the C ABI that Luke was talking about, kind of those header file ideas and kind of all the discussions we've had about ABIs. This is actually what toolchains are emitting that we have to deal with. Now, the actual way to actually create components, this is from WIT component inside of the WASM tools repository, and almost everything goes through this. So, and the unit of the primitive to be operating on here is that there is a core module coming in. It's got some metadata attached to it, embedded within it, and that is used to actually create the component itself as a result. And then after that, we get to do all sorts of kind of standard tooling. We can whack between multiple components to make more components. We can take components and run them in Wasmtime. Wasmtime is then also heavily based on the actual WITs that you were originally generating from with a guest language. This is sort of like the shared point between. This is sort of generating bindings in Wasmtime. This is where the WASI creates come from. This is where all the bindings come from, and yada yada. And then finally, we have Jacob here as well. That is, for example, an alternative runtime where you can kind of take this component and run it in multiple places. So the general experience, though, is folks don't actually go through every single one of these boxes. We tend to want to bundle these up into kind of one command. So for example, in Rust, you just say build with a particular target. You can use a targeted compiler with Clang, and then run all this inside of Wasmtime. And again, I'm saying that this is sort of the high
What?
level idea. Oh, yes. Oh, so this is sort of the high level idea of kind of how these are all going together. But each toolchain is a little bit different. So for example, in Rust, we have sort of this generate macro with the WIT bindgen crate, and we go straight to the component with the WASM32 target. Under the hood, it's still doing the core WASM thing, the WIT component thing with WASM tools or WASM component LD. But we have other examples. So for example, the Go toolchain will actually be a little bit more literally like this, where right now Go still emits a core WASM module, and the WIT bindgen Go is literally generating Go source code that you are including. But componentized Pi is totally different. At componentized Pi, the tool just bulldozes all of these and goes straight to a WebAssembly component after ingesting both WIT and Python at the same time. But again, under the hood, this is kind of all what's happening. Like Python itself was compiled with C, it's got a bunch of core modules, all of that's thrown together in WIT component, all that fun stuff. So the other aspect that I want to highlight here is that we don't, as the Bytecode Alliance, have necessarily control or shepherd all of these dependencies. So we do have we do actually shepherd a lot of it, things like WitBindGen or Jaco or Wasmtime and the Wit component tooling. But there are very much aspects that are outside of our control or outside of our like kind of what we are deciding. So for example, the Rust programming language has its own release cadence. LLVM has its own release cadence. Python has its own decision about whether it even wants a WASI target, things like that. So we are operating in this space where we are sort of kind of a layers around the tooling, and we have some injection points that we have a lot of leverage and control over, but we are operating within the context of other languages and other ecosystems that have their own priorities, their own release maps, and that's something we have to be cognizant of, and it's kind of how we frame our discussions to this and everything like that. So a lot of what Luke has been talking about is sort of the new features that we want to bring to the component model leading up to the to 1.0. And so a lot of this talk, I want to kind of focus on how exactly we've been thinking about those and sort of a little bit of a roadmap of how we can be implementing those kind of at a little bit of a finer grain detail, sort of. So the first thing that I want to go over is sort of the principles to think about with new features in the component model. So this is one where the general idea is we are in a preview stage. We call this WASI P1, P2, P3 for preview 1.1, whatever you want to call it. But we are not in a privileged position of just breaking everything. We actually have a lot of users. We actually have a lot of folks using all of this. So we don't have options available to us where we can just change everything and break everything on a whim. We have to do this in a way where all previous features and components and everything continue working. Luke already mentioned this, but I definitely want to emphasize this aspect of all of this is effectively stable, and we have to operate as if everything we've done is effectively stable. And we're designing for a future where we can eventually ignore this stuff, but we have to assume that all of it has to continue working in the meantime and have migration paths and such. The other aspect here is that from a development perspective, we very much need to ensure that the final WASI 1.0 and component model 1.0 is a subset of whatever you happen to be able to do with WASI P3 at the time we cut that off. So it's not today's WASI P3 because we're currently missing co-op threads and things like that, which we obviously want, but also all the features that Luke was mentioning. But this is a very key, important aspect of the development cycle in the sense that we can't stamp something that we've never tested before. We can't stamp something that's not actually integrated everywhere because we need to get implementation feedback. We need to make sure it actually works. And so that's the aspect here. We need to have the goal is to have a subset of the final development of WASI P3, and then that is what is stamped as WASI 1.0. That's what browsers in theory would be trying to implement, or the runtimes would be trying to implement. And so Wasmtime is kind of the most burdened here, where Wasmtime, as sort of the pioneer of the component model, we're going to have to keep all this historical baggage for a while, but other runtimes may not have this. And this also matters from a guest toolchain perspective, where uh, the vision we have for a component model 1.0, if a toolchain is relying on a feature that is not part of that, but is in WASI P3, that is a bug, and we need to fix that. That is a priority of we need to shift all toolchain development over time as it's appropriate to the subset that will become component model 1.0. We can't be relying on things accidentally that we haven't actually shipped just yet. Uh, this is, I can already mention this, but basically we need to be able to produce what looks like the WASI 1.1.0 component right before a release. So you can imagine that I could, if I turn on a validation predicate where I say turn off all the WASI P3 features that are not going to become 1.0, we have to be able to produce that component ahead of time. This is, again, critical for testing, critical for making sure this all is actually integrated and make sure this actually integrates into all the ecosystems very well. Another aspect is so we don't control things like Rust or C or Python or anything like that, but we need to be doing all this development upstream in those ecosystems. We cannot have a bunch of forks, a bunch of libraries, and call that this is WASI 1.0 compatible. We actually have to do a legwork ahead of time, and this will delay a lot of roadmaps. This will delay a lot of times because it takes a large amount of effort and kind of working to get all this upstream. But anyway, that's sort of we want to focus on upstream development. We want to focus on kind of engaging with other ecosystems. And if there are concerns, we have to address those and work with those and all that fun stuff. And I know Luke was mentioning that we probably want to sort of auto convert existing components to WASI 1.0. I think that's kind of a reach goal. We very much do want that. But exactly how this is going to work, how difficult it is, how viable it is going to depend on the decisions we make along the way, how far along tool chains are, how many components we have to migrate. So we'll kind of see this over time. So, okay, the next thing I want to talk about is sort of a general roadmap for how these features are going to be implemented. This is kind of a lot of what Luke was describing will fall into this sort of bucket. And this is kind of a little bit of an answer to what Bailey was asking of how folks can be injected. So the high level idea is first you start with a specification. This is the component model repository. It has the canonical ABI.md and explainer.md. This is not kind of like mathematical formal semantics quite just yet. It's still mostly English prose in terms of formal semantics, but the idea is we get agreement on what we're going towards, but not necessarily the perfect details just yet. Typically, what follows on next is that this is then implemented inside of WASM tools. This is sort of the binary format, the text format, the validation, and also where we start to actually create components, where you can write raw textual components and create components, but it's not particularly usable just yet because we don't have guest language integration. But the general idea is this is a feedback loop where this starts providing feedback to specification, which then starts going and updating as well. And so once WASM tools is then done, we tend to start implementing things in Wasmtime. This is the runtime side of things, runtime semantics. We get some tests. We flesh out the embedder API, all the various things there. And again, this is another feedback loop, which feeds back into the whole process. And then one of the later steps is the whole with bindgen integration of this is kind of, again, not literally with bindgen per se, but sort of language integration where we actually start being able to write code that is in C or Rust or Python or whatever. And we can actually use this feature. We can actually write some tests in that, get the whole end-to-end testing through Wasmtime, through these languages. And often that does happen in the with bindgen repository for at least the initial steps with Rust. And then the final step, which kind of sometimes is a little broken out of this feedback loop, is guest libraries and guest toolchains. So, for example, Joel's work recently to get WASI P2 support in Mio, that was involving getting a lot of support in WASI libc, then getting that into Mio, kind of working with the constraints there. But there is a lot of work to be done in terms of getting this into not just Wasmtime or component model specific things, but also kind of integrated nicely into particular languages. So there's a number of gotchas I do want to highlight in terms of implementing all these sorts of features. One is obviously the initial design is very rarely the final design. For example, we actually had async in YZP2, but we decided to defer it, and it was nowhere near as good as it actually currently is because we actually had time to focus on it. But just the general idea is all of this should be expected that whatever we come forth with, it should be an expectation that that will actually change. It will not be the final design. It will require some tweaks over time. Kind of depends on the feature. Another aspect is that reviewer bandwidth is often one of the major limiting factors in all of these features. This is not just on the spec side or on the Bytecode Alliance side or on the Wasm Tools side, but this is also on the upstream side. So engaging other ecosystems and trying to get reviews from them, trying to engage, and this isn't just literal code review, but also sort of design review and sort of ideas there and kind of the thrust of WASI and everything. That can take a lot of time. So we definitely need to make sure to budget a fair amount of time in that regard to make sure that this is taken into account. Another aspect is there's a lot of stuff here, especially like, for example, component or API design in Wasmtime, which doesn't really have a lot of precedent. So we didn't really know what to do with this accessor type or run concurrent type. Or I would also say that Wasm GC support was very much in this bucket for Wasmtime. It was kind of a little unclear of how to write a GC API inside of Rust, which doesn't have a GC. And so this is something to budget for, that can have a lot of gotchas of when an initial feature comes into Wasmtime, we're not quite sure how to shape it, or maybe how do we exactly expose? I mean, threads are a little more direct, but like the map type, map of KV in WIT, how exactly do we do that in JavaScript or in Python or in Rust, and mapping all of those down? There can be interesting questions there, so there can be some roadblocks or some various gotchas like that. And then finally, there's a lot of release cycles we need to manage. And so, for example, we've got Bytecode Alliance projects that we generally control. We can kind of do on demand, but LLVM, for example, is once every 6 months. Rust, once you land something, is about 9 weeks to become stable. User libraries have their own various things. So, example, like for the Mio or Tokyo crates, their own release cycles. So this is very much a concern in terms of if we want to plan all these out, we have to line everything up and kind of consider all of this to make sure that we're kind of landing in a spot where we can land changes, we can eventually get to testing these changes, but it all takes that into account. And then finally, the final gotcha is that we, bugs here can be sort of, unfortunately, very disruptive in terms of if we rely on a bug fix in LLVM, if it requires like bigger factorings, that kind of delays everything by about 6 months. If backporting is not a possible thing, or kind of backporting can require a lot of engaging of the process ahead of time. So this is where we very much want to kind of have this all as fleshed out as possible at each step along the way. This is kind of thorough testing, thorough as much as we can, the fuzzing aspect, kind of basically this is just something to keep in mind of that. Keep in mind of if a bug appears, what's the process going to be like for how do we actually push through that bug, fix that bug, and get that through. Okay, so the final aspect I want to talk about in terms of new features is sort of this high-level concept of versioning, which we haven't really touched too much on. So as Luke has been mentioning as how we can actually separate is the component model is distinct from WASI. So component model doesn't have versions right now, but WASI does have versions. But I would also say that for all intents and purposes, practically these actually are pretty much the same, and where WASI 0.3's flagship feature is async, and that's also the component model's flagship edition at that time. So what I'm kind of saying is that while WASI hasn't had version and component, or WASI has had versions and the component model hasn't had versions, I think we kind of want to consider the component model as being versions somewhat alongside WASI, maybe in lockstep for now to make sure we don't have too many versions in play. But the general idea here is that eventually these will start diverging. But for the meantime, on the development stage, I think it'll be kind of reasonable to say that we can say there's a particular snapshot of the component model repository, the component model specification, which we can say that this is 037 at the time, and this particular component validates with that. And this would be similar for Wasmtime, of the feature flag would say I would like to turn on some particular feature. This is a proposal. We have a little bit of bike sharing to do here, but the general idea is that this is providing a set of shared terminology by which we can all talk about component model features, component model versioning, WASI features, and things like that. what this is more or less in theory boiling down to is that let's say we add co-op threads. Let's say that the next WASI release is O.3.3. I think what we would kind of want to say is that while that co-op threads is not affecting the wits in any particular way, I think a WASI we want to push for saying a O.3.3 compatible runtime does have support for ungated threads or ungated co-op threads. That'd be kind of an example. Let's kind of push through that. So this still, we need to have a lot of discussions about this, especially in sort of a standards venue, standards forum. But I think we do want to sort of consider this of as we add these features, we still want a sort of discrete step along the way of this particular WASI version is now going to assume that you have the previous component model features that are done and have some sort of like marching forward. So okay, any questions or anything? Anyone want to say anything before the next steps where I talk about some more specific features? All right,
There are no questions in Zulip yet.
sounds good. So, okay, I want to sort of categorize some of the features that Luke has been talking about and also sort of categorize how at least I personally feel about them. So I would put these in various buckets of small, I think I'm going to say, let's see, less small and not small. I was going to put it up here. So small features I would consider this list, error context, optional imports. A lot of this is uh, there's not too many open questions in terms of the spec design or the guest language design. It's relatively straightforward. We kind of generally know what we're doing. We kind of generally it's pretty well defined. It's unlikely to have too much feedback in that feedback loop, and so a lot of these are pretty easy to get started. This is the following that standard specification, WASM tools, or Wasmtime with bindgen. Kind of blow through all those. There's lots of stuff, context in each of those projects. Each of these features will touch different portions, but the general idea is a well-motivated individual can make some good progress on these modulus, some of those gotchas I was mentioning in terms of like reviewer bandwidth or timelines up through projects, things like that. Some of the less small features, this is where the exact design is a little bit less clear. So we don't exactly know exactly what the GC ABI option is going to be. There's some questions about how exactly would variants look? How exactly would the intrinsic look? Or maybe this is blocked, for example, on the lazy ABI changes of how exactly would the lazy ABI stuff look with GC ABI? So a little bit more of an open question there. But I still say they're somewhat small in the sense that they don't have a massive impact on their runtime necessarily or on kind of new foundational features for languages. So, for example, callbacks are kind of going to unlock the ability to write callbacky looking code inside of a guest language, but you just can't do that today. And so it's not sort of changing what you're currently doing. This is in contrast to these sort of not small, very large features, which are massively changing what you're currently doing today. So all of the ABI changes affect basically every single tool we've ever written for the component model. So if we want to change with lazy ABI or the C header idea or changing the literal ABI or taking advantage of multi-return, all of that is going to touch every single tool everywhere and will take a very large amount of time and effort to push through at the same time for all of these. And co-op threads is similar where it's sort of unlocking code you can write today, but it's a very large shift of everyone has assumed threads don't work and every library needs support for that to now it actually all of a sudden does work. So I guess I've sort of already kind of dived into a lot of all this stuff, but like for example, a lot of the ABI stuff will require touching LLVM. This is where this dependency chain goes pretty deep. LLVM doesn't really have support for multi-returns right now, especially at like the C or the Rust level. Kind of at the IR level, there's a bit of support. We still haven't figured out what exactly the C ABI is going to be. And if we change it, it's a little unclear how we're going to change that because then you have stuff that used it beforehand and stuff that used it afterwards. And then the aspect of ABI kind of, I've been mentioning that the final snapshot for WASI 1.0 was a subset of what WASI 0.3 supports. So we probably need some sort of, the ABI is so fundamental, we need some sort of tool to effectively translate today's components to the lazy ABI components. And that's a pretty big project inside of WIT component. And then co-op threads and streams kind of have a lot of aspects, especially streams in terms of mapping into various languages. Co-op threads, just from the implementation perspective, we've already seen, Joel was mentioning, we have to work through, or Joel and Sai to implement this in WASI plumb that through a lot of tool chains, get that in Rust, get all the testing there. And writing a threading library is no small feat. There's a lot of features going on there. So I want to give a bit of example of sort of one way to think about all of this in terms of kind of decoupling things versus the hazards of coupling things. So let's talk about just the ABI changes and some dependencies involved here. So first we can follow what I was saying earlier of the standard thing of if we want to change the ABI, we specify it, we implement it in Wasm tools, Wasm times, and WIT-bindgen. So we've got all that done. However, we can't actually do the WIT-bindgen support because part of the ABI changes is using multi-return. But so we don't even have support for doing that in Rust. So we can't even actually do that in the Rust generator, for example. We might be able to do it in C, but also C doesn't exist. So we also have to do that in LLVM and specify what does it mean to do it in C. So now that's dependent on that. And because the Rust side is dependent on the LLVM side in terms of Rust doesn't really want to invent a new ABI. It's kind of we have to invent the ABI and then tell everyone exactly what to do. But then that's also dependent on what exactly is this C API or what exactly is this header file looking like in terms of how many return values do you get or what exactly are we actually translating this to in the in-memory representation. And so that's all dependent on the spec. And so we all of a sudden, if we try to do all of this at once, we have all of these sort of interlocking dependencies, which are a little difficult to make progress on because there's not a lot of opportunities for a feedback loop here where if every it's kind of LVM is in the middle or all these upstream tool chains are in the middle, it's difficult to kind of do that and make progress. And then when we finally get around to this WIT component rewrite, which then actually takes the existing components and rewrites it to use this new component, we'll find out that kind of these are actually major projects, kind of Wasmtime implementing and supporting multiple ABIs, with Bytecode supporting multiple ABIs, with components supporting multiple ABIs, add into the fact that LLVM's release cycle is quite slow. Rust's release cycle is then delayed after LLVM's release cycle and is also 9 to 12 weeks. We get into the kind of this morass of there's just a lot of stuff tied up here. So this is, I think, an example of if we try and lump too many things together, we're going to kind of have a bad time. This will end up kind of artificially delaying things, artificially kind of making things, pushing things down the road, largely for things outside of our control in terms of like the LLVM and Rust and upstream release processes. So instead, what I'm basically I think we should push for is to try and separate things out as much as possible. So have lazy lowering be entirely independent of multi-return, which is entirely independent of a new API, which will line up exactly with what the C API defines. This does mean that multi-return, for example, still has a bit more of a large release cycle because that is affected by LLVM. However, this is one where it's a little bit more clear in the design. So right now we have this limit in the ABI saying you can have one return value, and the implementation of switching that would be turn that to 16 or turn that to some other value. And so it's relatively obvious from that perspective of what the spec changes are. So the spec is kind of much easier here. Anyway, my point generally being that this is an example of we want to split all this up as much as possible, keep this all as parallelizable as much as possible, and this will increase the maintainership burden. This will increase the sort of implementation burden, but I think it's sort of this is kind of what we need to push these features and actually get them all landed roughly at the same time on the WASI 1.0 or component model 1.0 timeframe. Okay, so a few final things. I don't want to take too much longer. Is I want to give a bit of an overview of what WASI is today. So today, all testing of WASI P3 is actually going through WASI P2, and then that happens to also import O.3. So we don't actually have the WASI WASI P3 targets just yet. C and Rust exist, but neither of them are shipping. A lot of this needs to work in WASI libc, the primary dependency point. So if you're interested in helping out, that's kind of a primary point of getting WASI libc up and running. Then we can propagate that to WASI SDK and Rust. Um, there's a lot of ecosystem integration work independent of WASI P3, but also with WASI P2. So for example, this is Joel's work inside of Mio and also getting this inside of Tokyo, but the further extent of getting component model level async integrated into language level async is still going to be an ongoing question. For example, it's an open question of how to integrate the component model level async into Tokyo. And then there's a few more final aspects of Wasmtime's component model async implementation. We've been discovering a steady trickle of panics over development, so we definitely need to be working on the fuzzing and testing story there. And then kind of Sai alluded to this with the threading aspect, but there are certain performance profiles that might need some work depending on if downstream embedders actually end up hitting these cases. So for example, composition is going to become a little bit slower in the sync to sync case when concurrency is enabled, things like that. If that is a priority today, it means that we have some performance work to do. But otherwise, the performance that we have done is kind of like HTTP performs just fine, and all of that performs as expected. So that's sort of the general ish for where WASI P3 is today and kind of where it needs to go. So okay, this is kind of this has been a little bit meandering, but this is sort of the summary aspect, which is that so I do want to emphasize that a lot of the features we have are parallelizable, modular the whole human aspect of reviewing and implementation work and all that. we very much want to keep it that way. So, for example, the ABI changes, I think we need to make sure those are nice and split up and parallelizable as much as they possibly can be. I do think we want to start shifting towards a model of WASI 0.3.x is saying that a feature is ready and that we would say that runtimes only advertise as supporting this unless they support that feature. And then languages, when they upgrade to that WASI version, they can say that they now require runtimes that have that feature, or they can assume that feature exists. All this upstream work instead of LVM, Rust, and various other upstream crates and libraries, or just any language ecosystem, we always need to prioritize getting that as soon as possible in pipelines because of various timelines there. Um, and yeah, so okay, the other aspect I do really very much want to emphasize is that I've been talking a lot about various features here, but kind of from the WASI-P3 aspect and kind of maintenance aspect, a lot of this is going to be pushing forward the component model exactly as is today with our continued maintenance, continued improvement, integration into ecosystems. So it won't all be necessarily focused on new features and things like that. It's also kind of pushing on the existing ecosystem in that respect. Okay, so I intended to leave more than 4 minutes for discussion, but this is these are the slides that I have, so I'm happy for discussion and questions now if folks have that.
So we will take some questions now, but in relation to the break that we have coming up in 4 minutes, it will be a bit of a water cooler session. So, of course, it is going to be recorded and it'll be available afterwards. So if you need to take your break, absolutely. But otherwise, grab your water and join us around the water cooler as we continue talking about this. But yeah, if there's any questions, especially if you're on YouTube, please get them into Zulip, and I'll relay them here. And folks, if you're on the call, feel free to unmute and let's get at it.
Wow, Alex, that was awesome. I'm a bit stunned, but would you mind, because I'm very selfish here, and would love for you to talk through one of the small, easy changes, concretely, like just put up a PR this morning in relation to issue 287. That's the implements with parameters. What would be your ideal process for the next step after that? I think from your slides, and you had a really great flow diagram if you want to speak to that. But essentially, I think the next place would be to talk about kind of a sketch and an issue in WASM tools, or would you prefer to collaborate around code, like put up a draft that's like, this is sort of the idea here.
No, that's a really good question, and this is one where eh, it's not really, it kind of depends on the exact feature per se. I think personally, what I would say the best way to go is to have a PR on the component model repository exactly as is, and then leave that there. So don't merge it, but kind of have that being a living document in the PR. And then we have a second PR inside of Wasm Tools, which is kind of the discussion around that, where I find personally, at least, that the actual code implementation will very heavily inform discussions around this. It kind of makes things concrete, makes it so we're not talking a lot less in hypotheticals, but it's like I ran this tool and I have the test. And so for this WIT feature specifically, I expect that the one of the biggest things here is going to be the design around WIT, the design around encoding and serialization, and kind of getting all this fleshed out inside of WIT itself. And so the WASM tools side is probably going to be the biggest one. And so thankfully that's kind of the tightest feedback loop of those two. And so that's what I recommend is having the spec PR open, having the WASM tools PR open, and those can probably land simultaneously once we're kind of pretty comfortable with all those. And then for that specifically, I expect the Wasmtime and the WIT binds and implementations would be relatively simple to follow on afterwards. But I can actually speak. Luke also mentioned this, but Yordis has been doing fantastic work for map of KV, and so uh, he's already got some PRs in terms of the specification, then Wasm tools, and there's a Wasm time PR open, and that I can I'll link those in Zulip afterwards. And that's a great roadmap. Those have been going really well so far, in my opinion, in terms of having like this sequence of implementation steps and kind of handling all the gotchas and getting a lot of tests as well along the way before we get to, and then WIT binding would be the next step there.
Yeah, and the other shout out there for Yordis is that he's a new contributor in many of those projects. And I agree. It seems like that's been, from the outside looking in, looks like that's been going great. I bet he wishes he had this presentation before he started, but yeah, awesome. Thank you.
The water cooler is here, folks. You are more than welcome to chime in. We're all friends here in the BA. We're literally an alliance, folks. Like, you can get in here.
Um,
Uh,
oh,
question. When will we opt to break apart WASI and component model versions? Right now, coupled to decrease release, maintainer stability, and overhead.
I think personally, I would probably say once we're more ready for the phase 4 style stuff for the component model. And so I think that would sort of be that we're still pretty far away from that branching point, but I think we would probably branch to like some 1.0 RCs around that time for the component model. And then WASI itself would continue to evolve with its own WIT APIs. And I think the rough expectation around that point is we would fork a 1.0 RC that would delete a lot of stuff in WASI P3 that we do not want. That would clean up the binary encoding. That would be a kind of like shuffling a whole bunch of stuff. And then that is the target for browsers. That is the target for kind of runtimes that don't want all this historical baggage. And then all WASI development assumes that's all we got.
Got it. Joel.
this one's for Luke, or not, sorry, not for Luke, for Alex. I was a little surprised to see that you included optional imports as a small project. I felt like in the past we've discussed it and it felt like it was going to touch a lot of things. And I think you've posted some issues that I maybe need to just review. So just you feel free to tell me to just go back to that. But I'm just curious how you're thinking about it now and why you feel it's small.
This is actually a very important caveat. I say small here. All the floor for small is actually still non-trivial. So I don't think any of these are like a weekend project. A lot of these are still pretty significant in terms of implementation. So I would answer your question of I actually still think that optional imports is more or less the same amount of effort as it was beforehand. But I think I'm describing it, I guess, small relative to some of these other changes and small in the sense of like it's an extension of the component model, which is it's sort of the smallest possible extension of the component model in that sense, where it's like a nice localized feature that doesn't affect too many other things. But it is actually really important to call out of a lot of this does require relatively significant investment in terms of there's a lot of code bases to get into, a lot of reviews to be had, a lot of language integration aspects to be thought of. And for example, with optional imports, I think it's relatively straightforward. So we'll have some sort of WIT bindgen option that C is optional, and you get some sort of optional stuff in Rust, for example, or nullable pointers in C, or things that are just none inside of Python, yada yada. But doing a lot of that work, doing all that plumbing is still relatively non-trivial. And so I'm, I'm saying small from the number of open questions perspective and kind of the number of things we just don't know and how much that feedback loop is going to be required versus how just you can just do it and just go straight forward to the bottom.
Yeah, I guess I was feeling like there were still some open questions, like if we were, because at one point we were talking about doing sort of like a contained version that wasn't the whole version, and then are you so I'm still not 100% clear on like, and maybe I just need to go back and look at the GitHub issue, but on it felt like there were still some open questions, but maybe those have been resolved.
No. That's a good point. And this is one where I think for optional imports specifically, we sort of had the idea of we might want to ship kind of a halfway thing, which is like not the full thing, but halfway, but like just the not integrated with the component model, but just the tool chain.
Mhm.
And I think we've more or less sort of acknowledged at that point that's probably just a bad idea. And I don't think it's going to work. So we
Yeah.
haven't actually done that work. And so I think we've decided that that branch of work is more or less just dead. And we
Mhm.
actually need to just integrate it into the component model and go that route instead.
Sounds good. Thanks.
We've got another question from Bailey in the Zulip chat. Where is map in this iteration slash feedback process? What will be the point where we say it's shipped?
I would say that map, or wait a minute, I'm going backwards. I think map is at the Wasmtime stage just now. So it's done. So we've got the spec for it. We have the Wasm tools integration, and then Wasmtime work is ongoing. And the next steps would be wait by gen and then pulling that into various APIs as necessary. The second question here is kind of the shipping aspect. That's actually a really interesting question where I haven't really touched too much on that, but the general idea is kind of what I would like to consider this is that at some point we as the subgroup, or I suppose we as participants of the subgroup, and then we as participants in the standardization process for the component model, everyone will decide it's done. We're happy with it. and the next version of WASI has it ungated. And that would be whatever version of Wasmtime that happens to be in, we would ungate that. So leading up to that point, it requires opt-ins, gates, no one can use it by default. And then that decision point is where we say, all right, let's turn it on. And WASI itself may not use the map type just yet. Like maybe there's not some new API using it, but part of that release would be uh, embedders and languages and things can now start using this.
Victor.
Hey, can y'all you may not be able to see me.
Can't
Can
see you, but
share
we
your
can hear
screen, I
you.
think. Okay, great. So you should be able to hear me now. I didn't see me. So I wanted to ask if there's any sort of appetite around reorganizing the canonical ABI documentation. So this is the stuff that basically is in the component model repo into sort of stages. Let's say like across, let's say P2 features, P3 features, and then all these features that are coming now. Because looking as a sort of implementer or anyone who might look to try and sort of build all of the sort of machinery that we've essentially worked our way up to, it's really daunting to look at a massive list of essentially built-ins that you need to support. And ideally, anyone who's looking to implement the component model is from a host point of view, should be able to sort of step through features, right? To like, let's say, implement resources and then implement context, let's say, and then implement sort of back pressure, or at least as far as things can be sort of broken apart and thought of individually. And it'd be nice if that was sort of reflected in the sort of organization rather than necessarily one massive document.
We do have emoji gates that tag things. So you can search for the emoji, and that kind of slows you slices. And as we add new features, each one will have an emoji gate. I've also thought the lazy ABI will take a lot of stuff that's in the canonical ABI and delete it. If you only support the lazy ABI, you just didn't have to read that stuff. So I have thought about maybe just to make it less daunting and to strip some of the scarier parts, particularly the auto back pressure and the string transcoding that I mentioned, to maybe make a copy of the documents, or maybe, I don't know if Markdown has like a little collapsible things, make things hidden by default.
It does. Supports
Yeah,
the
so I was
summary.
hoping it did, because it two documents seems like it suck. But so have the stuff that you don't have to care about if you're going straight and only to lazy, auto hidden by default, and so that would be a thing specifically to, yeah. So so that's something. But yeah, I guess all future features, since we emoji gate them, we have this kind of process, an official process, or kind of official process of emoji gating each new edition. Everything going forward is going to have one. There's one big emoji gate for like all of async. I guess it could be subdivided if we wanted to talk separate context.get, but a lot of the other stuff's all kind of in one group, which is doing async, which is all has that async emoji. Yeah, we can talk about that, particularly once we do lazy. I think there'll be a refactoring appropriate.
The one thing I would add on to
Thank
that
you.
is that I think the smashing tool that Luke was mentioning is actually going to be really, really helpful here, in the sense that if you produce a component that only talks with integers, you would expect that the final component doesn't actually use a lot of intrinsics. It would only talk about integers. And so I think it's sort of our responsibility as sort of toolchain maintainers to say that if you produce a minimal looking component, it actually uses as few features as possible. And then that smasher would produce a thing that doesn't actually import a bunch of intrinsics. It would only talk about a few particular types. The rough idea there being that you could take test cases at a time, and you could start importing this component. You could panic on everything you don't actually care about or you don't actually understand just yet, and kind of incrementally work in that regard, sort of work from a small feature set up to a larger feature set. And I say the smasher thingy specifically in the sense that like that boils away all the component model aliasing and instantiation and yada yada. You sort of just get the core module aspect, which I think is a lot of folks will resonate with a lot better in terms of understanding.
Cool. Thank you.
So I see. Oh, good.
Yeah, just a question that we got in the Zoom chat, which I appreciate was being actively moved to Zulip, but we're still going to address it live because this is a water cooler, baby. We can talk about anything we want. What are the plans around exception handling and garbage collection Wasmtime? When can we expect them to be tier one on by default? When, like, and I want to know this too. So, what's up?
I can give my own thoughts, although Nick, I assume you're on the call and you can also jump in as well. So right now the major thing blocking, or rather for Wasmtime, the only blocker for exception handling is fuzzing. We don't have tailor-written fuzzer for exception handling, and we just once we get that online, then Wasmtime's basically all of our requirements are met, and we would turn that on by default. For GC, I think it's similar-ish, where fuzzing is a, sort of a major missing aspect, but that's been worked on, I believe, very actively by Khan with Nick, and then the other aspect for GC is the C API. So we don't have any support in Wasmtime C API for that. That's a major missing piece. So I guess the way I would phrase it as there are technical blockers inside of Wasmtime's release process, or kind of our own feature requirements, or requirements for turning features on by default that we haven't met just yet with those two. They're relatively straightforward in terms of what they are. And then in terms of timeline, I think it's mostly waiting on a developer slash maintainer to be sufficiently motivated to actually perform that. I think that just hasn't happened yet. So as things progress, like I know, like there's been a lot of activity and interest in C++ exceptions, and I think that'll be that is a forcing function for getting fuzzing done for exception handling and turning that on. And GC would be similar. So some language comes along which would be motivating for a implementation here. But Chris or Nick, I don't know if you want to add anything else to that.
Go ahead, Nick, and then I'll add.
Okay. Yeah. So I also threw in Zulip the like WASM proposals documentation page that we have, which lists all of the actual blockers for kind of turning things on by default and the current status. The other thing is right now we have two collectors. We have a null collector, which will just allocate until you run out of space and then trap the program. And we have a deferred reference counting collector, which is a reference counting collector, and it does not have cycle collection. And so if you create cycles, they won't be collected until the store is collected. And that's fine for actually probably turning this on by default, I would think. But it's not probably what you want to use long term. And so we do have plans for a kind of semi-space copying collector, but in terms of prioritization of actually implementing that for me personally, it's not clear when that would happen.
Yeah, and just to add a few more things. One minor detail: the C API for XNREST for exceptions is still not there yet either. So that needs to be in before we turn it on by default. And then the other thing is that, at least in the thinking around tiers of support, EH exception handling does use GC under the hood to allocate the exception objects. And so I have been under the impression that we sort of had this dependency reflected in the roadmap as well, right? So we can't turn EH into a tier one feature until GC is a tier one feature. But yeah, that can be discussed if pressure pushes us toward reconsidering.
I'm happy to pressure folks.
I would say, in my opinion, it's malleable. So I would say we would need to do some work, I think, to sever that dependence. But I do think we could get that work done inside of the engine.
Another thing for you, Alex. Bailey says, but exception handling is experimental in WASI libc on LLVM patch. Will you share some status there?
I definitely will. But wait, Chris, sorry, did you have one more thing you wanted to add to that?
Yeah, sorry, I was going to ask Alex about what you just said. So you said sever the dependence, meaning an alternative implementation of exception objects that don't use GC under the hood?
I
Something else.
viewed it as more of a kind of an alternative collector, maybe a collector shaped, which is a little bit more appropriate for just this. But I think but no. I would expect a relatively small amount of work would be done in Wasmtime to make kind of the defaults appropriate for GC being off, but exceptions being on by default, and that might be necessary. It may not be necessary, but no, I would not want to hold the implementation.
Yeah, I guess for context for folks, there was some discussion when we first did the EH based on GC around how small can you make GC. So we already allocate the heap lazily, only when the first exception object is actually created. But having it have very small defaults so that it's essentially equivalent to malloc the exception object, I think is what we would want there.
Okay, and I'm happy to address this, but we are at time. So do we want to? I can do this.
You have 20
now,
seconds.
Okay. Uh, oh God, I'm going to think for 10 of those 20 seconds. Set long jump is based on exception handling. You can link that in with via special flags. Just requires you to compile stuff. WASI SDK supports that natively. C++ exceptions will require a new build of WASI libc and WASI SDK, actually primarily WASI SDK. We do not have plans right now yet for what exactly we're going to do there in terms of when we will simply turn that on by default. New targets, new builds, a little unclear.
I think that was beautiful. And with that, the water cooler session is over. Please return to your desks.